Hi, good morning, and welcome to the ZP Developer Zone on the 5th of November 2020. We're obviously streaming live, and these. Good morning, and welcome to the. These webinars are intended for our members, so I'm delighted that you guys can join us this morning. So let me sort of dive into a quick, really dive into the webinar and the presentation this morning. So what I want to say first of all is, this is the agenda for this morning. So I just want to cover the developer zone, the news from the developer zone. I also want to discuss scripting, and I also want to discuss screen printed electrodes just very briefly. And maybe also I want to ask, next week, what should we do as a sort of topic for the ZP Developer Zone? All right, cool. I'm just going to say hi to Demas. Hi, Demas. Nice to see you. Right, brilliant. So let me just go forward very quickly and say, obviously, I do put this slide up quite a bit, but the ZP Developer Zone, we do have the Discord server. So if you want to ask any questions of me directly, I'll be on that Discord server. We do the webinars, and we also do collaborations. We are sponsoring PhDs. We are intending to do a workshop. We obviously do offer discounts off our products. Now, we do, as I say, if we look at our news, then the collaborations that we have going on, I think our most active collaboration at the moment is with Abril, where we're actually looking at Trypanosoma evansi, and Abril is actually, I think, starting to talk about this work himself in Indonesia. So I think he's attending online webinars or online conferences. And he's talking about the development of biosensors, and he's talking about the use of artificial intelligence in the development of those biosensors. So, when at ZP, we say on the previous slide, look, we're interested in collaborations. That is a genuine thing, that we generally want to do collaborations with the developer zone. So if you're a member of the developer zone, we're not yet collaborating, it's probably worth talking to Hasim about this and seeing what we can get going. So I think together we're much stronger than any of us are separately. So Abril's a great example of that. There's even an opportunity that Abril might be talking about this collaboration in Korea next year. So that might actually happen. We'll have to see due to the coronavirus. Now, Abril obviously is very interested in this parasite, so we have discussed that in the past. I'm going to change gears slightly because on my agenda today, I wanted to talk about the developer zone, which you're a member of. I wanted to talk about the news, and I want to say, look, if you do start collaborating with us, then we'll definitely put some resources into it. And then I also wanted to talk about scripting. So what I'm going to do is, so first of all, one of our members, Hasim, was talking to a professor, I think, in Indonesia this week. And I think the question is how do we do something called Anodic stripping voltammetry? So the first question might be, what is Anodic stripping voltammetry? So Anodic stripping voltammetry is the idea that you can detect heavy metals using electrochemistry. So I'll hold up one of our sort of screen printed electrodes. So the idea is essentially you would take a solution that contains heavy metals or metals, and you would put it into the potentiostat, sort of like this, and then you would put a drop of solution onto the electrode, and using a technique called anodic stripping voltammetry, you could or should be able to detect the heavy metals in that solution. So what happens is you apply a positive voltage, and that positive voltage is, we basically call it a cleaning step. So it cleans the electrode. So you'll put a positive voltage on there, and it cleans the electrode. What's that voltage? Maybe 900 millivolts. So you'll put 900 millivolts in it, and that will clean the electrode. Then you'll change the potential on the working electrode to a negative voltage. So when you apply a negative voltage, the metals, if you apply enough voltage, then the ions, like copper and arsenic and lead and cadmium and zinc, will actually electroplate onto the surface of the electrode. So rather than being in the solution as ions, they actually plate onto the surface of the electrode. So you did a cleaning step, then you did a plating step, and then you do an equilibrium step where you just kind of let everything come to an equilibrium. And then this is the anodic stripping voltammetry part, that you actually start taking the voltage in a positive direction. And if the metal is easy to oxidize, then it will oxidize first. So in this, for example, we go from minus 1500 millivolts, and the first metal to oxidize as we suit the voltage is zinc, then cadmium, then lead, then arsenic, then copper. So Hasim was talking to a professor, and I think they were looking at the software, and they were trying to figure out how can we do a process like anodic stripping voltammetry, and maybe they were trying to think about how to do heavy metal detection. And effectively, you can do it on things like the screen printed electrodes and the potentiostat, but you have to use a particular technique. Now I'm going to do is actually show you how to apply that technique. So what I will do is, so I brought up the software. So we sometimes sort of show this software in our videos and our webinars, but I'm going to show you that it's actually got a more sophisticated piece of, it can be more sophisticated than I've displayed in the past, because actually it's got what's called a scripting ability. So what I'm going to do first of all is, this is a scripting window. So what I'm going to do is I'm going to remove all of the things that are there. So what this scripting does is it's basically a series of commands. So when I was describing anodic stripping voltammetry, I was describing that we'd have to do A, B, C, and then D. So we'd have to clean, we'd have to plate, we'd have to equilibrate, and then we have to do linear sweep voltammetry. So that's what I want to do. Now the question is, how am I going to do it? And one way of how to do it is this, is you go into the software and you actually write a script. And the first thing you need to do is you actually need to turn the cell on. What that means is, it just means turn the electrode on. So you turn it on, then do a measurement. So I'm going to do a measurement, and the first thing I need to do is a cleaning step. I need to clean the electrodes. So what I'm going to do is I'm going to call it cleaning 1. And now the first thing I need to do is I need to say, what technique do I need to do here? And the technique that I need to do here is I'm going to do chronoamperometry. So what I'm going to do is I'm going to hold the voltage at a positive voltage. So this is what I'll do. I will go conditioning. So I will do no conditioning. I'll do no timeout conditioning. I'll do no deposition. I'll put all zeros here. So I'm not going to do anything pre-treatment. But now what I'm going to do is I'm going to say for 3 minutes, so 180 seconds, whoops, I'm going to apply, it's quite a lot of voltage, this is minus 1.5 volts. And I'm going to, I'm going to put 0 there because that was equilibrium time. So no equilibrium. Turn the cell on at minus 1.5 volts. Do that for 180 seconds. Nope. That's 1 second. What that is, that's the interval time. That's my save rate. So 0 seconds for equilibrium. Turn the electrode on at minus 1.5 volts. Have a save rate of 1 second, and we're going to do it for 180 seconds. So what that is, that's my cleaning step. So when I was describing anodic stripping voltammetry to you, I said I needed a cleaning step. So that's a sort of, and in fact, I've done it wrong because that actually needs to be positive. So let me just make that a positive. So I'll just make that 1 volt because I was actually doing the deposition step. So that's my cleaning step. So my cleaning, so I turn the cell on, I do a cleaning. And my cleaning is no seconds for equilibrium. Apply 1 volt for 3 minutes. Now the next thing I want to do now is I actually want to do my deposition. I actually want to now take the metal ions, like you're concerned that there's lead in the water. Maybe there's a well or something, and you're concerned that there's lead in the water. So what we need to do now is we need to plate that lead ions onto the surface of the electrode. So that's what we're imagining ourselves doing. So we're doing a measurement, and we'll call it deposition. Oops, create a new method. I'll call it deposition. And now what I'm going to do is I'm going to do chronoamperometry. But now I want to apply my negative voltage. So I'm going to apply negative 1.5 volts. That's quite a negative voltage from the in electrochemistry. We will have a save rate of 1 second, and we will do that for 3 minutes. So now we have turn the cell on, we have a cleaning step, and then we're going to have a deposition step. That's when we do the electrochemical reduction of the ions onto the metal surface. And then the next step then is kind of, in my set, I think we were going to do an equilibrium. Now, that could really just be another electrochemical deposition. So what I'm going to do is create maybe a deposition 2. And I'm going to, So the last deposition, I did it at minus 1500 millivolts or minus 1.5 millivolts. So I'll keep that there. I'm just going to do it for 10 seconds, let's say. And I think that's it. So now I have turn the cell on. Then I have do my cleaning step, do my deposition step. Maybe I should have called that my equilibrium step, but I've called it deposition 2. Now I actually want to do my measurement. Now this is my, and this is why it's called anodic stripping voltammetry, because we're going to sweep the voltage in a positive direction. And so the anode, we're going to go in an anode direction, from negative, which is often cathode, in a positive direction, which is often anode. So we're going to do a linear sweep voltammetry. So I'll call it linear sweep voltammetry 2. And then I'll edit the method. So I'm not going to do any equilibriums, but what I am going to do is actually change the linear sweep voltammetry. So it's basically asking me how long do I want to equilibrate for. Maybe I'll just put a normal 1 second. I want to begin at minus 15, minus 1.5 volts. I want to end at a positive voltage, and I'm going to put about 1.2 volts maybe, but maybe that's a bit too much. I want to step at 10 millivolts, so that's what my stepping voltage is. So it's a little stepping voltage. So and I want to have a scan rate of something like 10 millivolts per second. So every second it's going to change by 10 millivolts, and I can do save and close. And then I'm saving the output file as well. So what this is doing is this. I described that I wanted to do a, and this is one of the good things about electrochemistry, ICEPI. So what I'm describing here is that I wanted to do this experiment, again, where I was going to take one of these kind of potentiostats, take a screen printed electrode, put it in the front, put a solution on top of it, and then do electrochemical anodic stripping voltammetry. So I could detect whether there is heavy metals in the water, as an example. So I know that in some countries, when they make these big they drill big boreholes to pump the water out of the ground. Sometimes that water is coming out with quite a bit of arsenic in it. And so if you want to detect arsenic in heavy metal, or sorry, in water, you can use this technique. And literally you just clean the electrode with a positive voltage. Then you electrodeposit or electroplate the metals onto the electrode surface using a negative voltage. You allow it to equilibrate. And then you sweep the voltage from the negative potential up to the positive potential. And in doing so, you end up stripping, they call it. But basically, you get a peak for the zinc because that's the easiest one to oxidize. Then you get a peak for the cadmium because it's the next easiest one to oxidize. And a peak for the lead, a peak for the arsenic, and then maybe a peak for the copper. And the reason I'm talking about this week is because Hasim wanted to know how to do this. Hasim is a member of the developer zone, so I wanted to kind of help him understand that. So that was just kind of to show you, some more that the software that we have for running the potentiostats is actually quite sophisticated. So you can run, sort of a conditioning of the electrode, then a measurement on the electrode, then you could do a cleaning of the electrode, then you could do another measurement and another conditioning. So you can keep on making quite sophisticated routines, especially if you're going to try and do a route. If you want to have a continuous measurement of something, then you're probably going to have a measurement process and then a cleaning process, then a measurement process and a cleaning process. So that's scripting and will allow you to do that. So that's what we've discussed this morning, is how to make a script. I did want to just touch on a couple of things about screen printed electrodes. I was asked this week about the pros and cons of screen printed electrodes for doing amperometric sensing. So in amperometric sensing, you just apply a voltage and you measure the current. And if you do that, if you put a drop of solution on the end of a screen printed electrode and there's something electrochemically active in that solution, and you'll get a signal that starts off high and it falls with time. And this is because it's becoming what they call the material is being consumed by the electrode. And literally, this is a diffusion limited process. The material can't arrive at the electrode quick enough. And this response, we call it the Cottrell response. Now, the reason I described that is I was asked, well, if I run an amperometric type assay on a screen printed electrode, will my screen printed electrode influence my signal? And it will, because your signal or your current is proportional to the concentration of the material that you're trying to analyze, and also its diffusion coefficient. So, so you want, these are the things this is the thing that you're trying to measure here. And everything else is a constant. N is a constant, F is a constant, pi is a constant. T is because with time the signal is falling, so current falls with time. There's also another constant in here, which is the area of the electrode. So you can imagine that if the screen printed electrode does not have a repeatable working electrode area, then that's a source of variability. So if you're trying to make a biosensor or sensor and the area is too variable, then from sensor to sensor, you'll get different signals for the same concentration. And that is why it's good to have control over your printing and your working electrode area. I did contrast this, and I've slightly now. What I've done here is actually contrast this with potentiometric sensing. So in potentiometric sensing, you're trying to you're just measuring the voltage at the working electrode, and in potentiometric sensing, there's not. When you look at the equation, the Nernst equation, which we've touched on in the past, there's no area in here, but there is a term here which is it's called the cell potential, and the cell potential is the difference between the working electrode and the reference electrode. So that's meant to be a constant, but if the working electrode is a little variable, then it will affect this. So screen printed electrodes are very good, but if you don't control their manufacturing, then they introduce a variable into your measurement. And so if you had 5 electrodes and you put on the same solution, if the area was variable, then you would see it in your data because your current or your voltage would be changing, not because of the concentration, but changing because of the sensor variability. So we're very aware of that as in repeat loop, and that's why we try to make the best screen printed electrodes we can. So I'm going to finish up now because I can see it's so the developer zone exists. I think we've got a really nice case study with April that's ongoing. I can see that Dimas and Seppi are online. So guys, if you're interested in doing a collaboration with us, maybe drop a line to Hasim or myself and you can start doing that. The news is that I know April has started to talk in public about his collaboration, which is really cool. This week I made the main topic just to let you know about the scripting feature in the software. So if you own one of these potentiostats, you can actually do quite sophisticated experiments with it. And then I wanted to touch on how a screen printed electrode could influence the signal in an amperometric sensor. And in an amperometric sensor, it can influence the signal because if the area of the electrode is variable or changing, then that will make your signal go up if the area is bigger, or make your signal go down if the area is smaller. In a potentiometric sensor, it's a little bit more confusing because the area is not part of the equation. If the surface changes a bit, then it will change your cell potential, and that will put a variable into your data. And then my last note here is next week. So every week, well, it's really good to be able to use this webinar to answer questions from the team. So this week I was definitely answering a question about Hasim. I'm going to post this video in a bit so that he can kind of see the answer. But honestly, guys, if you've got any questions or you want to, have some insight into biosensing or electrochemical sensing or electrochemistry, just let me know through the Discord server and I'll be happy to answer them. So I'll just say any questions, guys, or just typing to the guys online. Yeah, so like I say, I mean, we do these webinars because we're very, we really believe in the developer zone. We want to sort of bring everyone, up. Well, we want everyone's research to go really well, and we would be really interested in some of you doing companies, and we're sort of here to kind of help you. So what I'll do is I will sign off now. It's been 25 minutes. I'll post this online in a short while. But I do appreciate it. Seppi and Dima, it's appreciated, and speak to you soon. I will be doing this next week, so I will catch you all then. All right, guys, I appreciate it. Take care. Bye-bye.